And if I was a young person, like let's say I was like an 18-year-old trying to figure out, what I want to do, it's not as easy as it used to be. Like it used to be, okay, if you learn to code, everything will be fine because we're always going to need programmers. It's not the case that that's true anymore.
Welcome to Humans of AI, where we tell the real stories of those who are building an AI or are making use of it in their daily lives. Today's guest is Meryem Arik, an Oxford-trained physicist and the co-founder of TitanML, which is an AI startup working to significantly simplify the deployment of large language models. Outside her professional life, Meryem dedicates her time to mentoring underrepresented groups in STEM and watching rugby. If you want to catch the latest episodes, make sure to subscribe. And check out my free AI newsletter, Chaos Theory, and find me on social at Alex Chowmander. Now, without further ado, here's my talk with Meryem. All right. Hello, everybody. I'm here joined with Meryem. She's one of the co-founders of TitanML, a new startup that's looking to create AI models that are local, that are more easily deployed, and probably give people more control over large language models. So I'll let Meryem do her intro, but just to kind of tee it off, Meryem, would you like to kind of describe what your origin story is and how you came to be where you are right now?
Sure. So I guess I have quite an untraditional path, I guess. I didn't study machine learning or computer science as an undergraduate or a master's student. Like my background is in theoretical physics and philosophy. So things that I was really interested in growing up was astrophysics and philosophy of mind and ethics. And that's kind of, what took me throughout my academic career. But I guess the reason I'm interested in all of those things is because I'm just interested in things and I'm interested in learning. And AI has always been, well, for the last kind of 5 years anyway, has been part of like the latest gen tech and like really, really exciting things. And so it's just been one of those things that I've enjoyed learning about, kind of like the same way I enjoyed learning about physics and enjoyed learning about, different philosophies of mind. It's just another really, really cool thing that I find interesting. So after I left university, after I left Oxford, I became an investment banker. I didn't really know what I wanted to do. And I really enjoyed being a banker because I was like learning a lot of new things. But I then moved into the startup world, mainly because what you get in startups that you don't necessarily get in big corporations is this sense that like you're building on something and you're like, building something that didn't exist before, which I found really exciting. So I moved into the startup world, and around 2 years ago, we founded TitanML.
Very cool. What would you say in terms of like your formative experiences? You talked about being very interested in physics and philosophy of mind. Like, I guess how has that maybe impacted this sort of path that you've gone? Because it sounds like the act of creation of something brand new is super
Yeah.
meaningful to you. So I don't know if parts of your background, maybe there's some trigger or something that helped lead you down this path.
It's a great question. Like I don't know why I'm really into physics and philosophy of mind. And I think like the answer that I crafted for myself when I was younger is that they're actually trying to solve the same thing. They're trying to both understand the universe. They're just going about it in really, really different ways. And I found that, really quite interesting. I don't know how AI fits into that though. I think like what I just learned through being really interested in physics and philosophy is like I learned that learning things is really fun and it's a really geeky thing to say, but it's really fun to learn things and it's really, really fun to do hard things. And it's this sense of like, okay, building things that people love and people use and want to use over and over again is really, really hard. Like it's not an easy thing to do. And I think that challenge is really motivating to me. I was definitely a competitive child when we think about like formative experiences. And it might just be the element of I just like doing things that are hard because I find it really fun. Yeah, I don't know.
One thing I saw on your LinkedIn profile is that you said that you were a rugby player.
Yeah, I'm very competitive. Yeah, I started playing rugby actually quite late in life. So I started while I was at university, and within about a year and a bit, I was playing at a pretty decent standard. And it's just a really fun sport, and it's just one of those things that I got really obsessed with, got really, really into, and turns out I had a natural ability for it. I did actually stop playing though a couple of years ago, mainly because it's not very good for your brain. And I quite like,
I see, I
keeping
see.
my brain intact. Yeah, there's a lot of concussions in the sport, similar with American football, right?
Yep, yep.
Um,
What would you say then are some of the parallels or maybe even the lessons that you carried over from rugby into even being a founder of your own startup today?
Yeah, it's a really good question. I don't know if like your listeners will be familiar with rugby, so I guess I'll talk a bit about like the culture as well of like the way that rugby works. So there's a couple things and that I'll try and pull out. One of the things that I want to pull out is that rugby is not a very enjoyable sport for like 95% of the time. And most people on the pitch are just doing like grunt work. And then there's one person that'll score the try and like be really flashy. I guess it's kind of like in American football, right? We have all these people, doing, defensive work, and then you have that one person score the touchdown. But in rugby, like you don't celebrate goals or tries as like an individual person's goal or try. You celebrate it as the team, because everyone had to do all of this awful grunt work in order to get you there and push you forward. And I think that's something I've really taken from it, is this element of like, it's really hard. We're going to stick together. We're going to pull through together. And, at the end, we'll succeed, but it'll be all of us that are succeeding, which I think is really wonderful. I was playing one of the positions that is more of the grunt worky kind of thing. I'm very tall. I'm like 5'11". So I was definitely that person that was, putting in a lot of grind and not necessarily, scoring all the flashy tries. And I think there's like a great amount of like resilience that you learn from that, and just kind of like you just got to keep trucking element that you learn from that, which is really, really nice. I think rugby has one of the nicest team sport mentality, like we're all in this together, that I'm not sure like every sport does. I mean, there was a quote on the side of our locker room: the strength of the wolf is the pack, and the strength of the pack is the wolf. And it's this idea that like we all have to push as hard as we can, and we will have to do it together, and then we'll kind of get where we want to go, which I really love.
Yeah, I mean, I can certainly hear those similar sentiments, especially in early company formation,
Mhm.
where you probably are maybe a handful of people with a dream and big
Yeah,
ideas, and it's you against the world, sort of thing. But certainly the collective is stronger than any like individual, um,
exactly.
by himself or herself.
Exactly. And I actually think that's something that is really underappreciated, that I see a lot of teams that I know where the sum of their parts is actually less than them individually. And I think that's like, one of the biggest multipliers you can get in success is if you can add up all of these people, and the result can be greater than all of those people put together. And I think that's amazing. Did you ever play any sports?
I played basketball. I played actually both more individual sports. So I played
Yeah.
badminton before in high
Uh-huh.
school, um, and then I really enjoyed playing basketball. Dabble a bit also in volleyball as well. So uh, and a little bit actually of American football, but that was more
Did
just for
you
fun.
Do you think you took any of that into who you are as a person?
Oh yeah, for sure. I like to say that, if there was a job or career I could do without having to worry about like money or things like that, it would just be like a basketball coach.
Yeah.
And it's because like I see that, especially in the team-based sports, right? It really is like if a well organized and well functioning team can for sure outshine even teams that have a superstar, like someone really talented. And that sort of, you can call it an underdog spirit, but it's really just this idea that, we all can, despite our own limitations, our whatever shortcomings we have, like we
Yeah.
can achieve something like really great together. So that's what I really
Yeah.
enjoy. And for
It's
me,
so nice.
I've adopted that in my own perspective, like approach to life, where I'm really big into just community overall. Hence even this like podcast where,
Yeah.
right, I'm just trying to meet with you know interesting people to hear their stories and to yeah, it's, whether we work together in a formal capacity or not, just see where things go from there because we're all journeying through life together and trying to figure it all out.
Yeah, that's really lovely. I really like that.
Yeah. So actually transitioning more towards what you're concretely doing with TitanML, um,
Yeah,
can you give me like what's the elevator pitch for it?
sure. So I guess there's like a couple problems that we're trying to solve. The headline one is that LLMs are really computationally expensive and they're really, really difficult to deploy. And there's a whole bunch of reasons why that is, but I guess like the long and the short of it is they're big and they're slow, and there's dealing with GPUs is really difficult. So we're working on solving that challenge from like a number of different layers. We think about ways that we can build smaller and better language models, like take language models and essentially compress them using a variety of techniques. And then we also think about ways that we can have the infrastructure be way more efficient. So how can we fine tune in a more efficient way? And then how can we deploy and serve in a more efficient way as well? GPUs are really scarce, so we're trying to solve that problem to some extent. So we were founded a couple years ago, actually starting in computer vision, and then have been focusing on language models for the last year or so, before ChatGPT, but for the last year or so, but working on those like inference optimization techniques and like infrastructure techniques as well.
Yeah, I think one thing that maybe is not as explored or talked about, especially for early stage startups, is the art of the pivot or the art of you know
Mm.
making a strategic decision to go in a different direction. Can you talk a
Yeah.
little bit about like why the shift from computer vision to language models, especially before ChatGPT got very popular?
Yeah, so we started off in computer vision mainly because that's where the most obvious like resource constrained environments were. So when you want to run things like properly at the edge, like I'm talking on phones or satellites, like you do with like a lot of vision models, compression and inference optimization becomes really, really obvious. And this, we were super early on. Like my co-founders were still in their PhDs. We weren't even on this full time at this point. Um, we started speaking to customers, and customers were like, actually, if you could do this for language models, this would be way more attractive for me. And it was this process of speaking to customers, and they were like, yeah, this is really cool, but actually, I deal way more with text than I do with computer vision. And this is something that we just learned through customer interaction, that in the enterprise or for businesses, text is way, way, way more common than images are, or actually most other forms, modality forms. So that's why we were like, actually, the market is asking us for these language models. Let's go work on that. So it was customer engagement, and then when we also thought about it, these language models are like 100 times more compute intensive than computer vision models. Even though they can be run on data center GPUs, they're still really expensive and really, really slow. So there's like a genuine need in this space. And it's a much newer space as well. So there's a lot of room for improvement. So yeah, a whole bunch of reasons why we moved into that. I can't say it was like a definite pivot, but it was just like a gradual, people over and over again asking us for this thing, we better listen to the market.
From my own experience, yeah, I worked on computer vision models quite a lot when I was
Mm.
working on self-driving cars at
Yeah.
Uber, and it was definitely it's definitely still a hard problem,
Mhm.
although it's usually some flavor of a ResNet at the end of the
Yeah.
day, and the underlying architectures are similar to what they were, at least to my knowledge, they're similar to what they were from a couple of years ago. And really, the innovation is trying to, like, okay, how do you augment data? How do you um, maybe explore different type of like sensor fusion
Mm.
capabilities or modalities,
Yeah.
and yeah, just trying to do a lot of engineering work to get that working. But in the large language model space, I think what I've been working on most recently at my time at Microsoft, yeah, it's we're seeing that it's just a kind of a brand new moment where people
Mhm.
are very captivated by what they're seeing in like ChatGPT. And obviously, yes, enterprises want to have that capabilities for themselves. They probably want to own the models, not just like call them from an external API. And but it introduced a whole host of challenges. So
Mm.
maybe, Miriam, I'd love to hear from your vantage point, what are some of these challenges that enterprises are encountering with large language
Mm.
models?
It's a great question. And it is a really interesting moment. Like, it's very, very strange that we'll have CEOs saying to their organizations, cool, you have $50 million, do AI. And then, business units are like, where do we do AI? Right? Like, that's a bit of a strange thing. So I reckon like the biggest challenge that we see is like businesses just being like, where do I use this AI? What is it good for? What can it do? What can't it do? Because, for a lot of these, business units, their first exposure to AI was ChatGPT. And, they don't have a huge amount of knowledge about like, what do these do? What's the difference between generation and understanding? What is a BERT? All of these things. So the first thing is, okay, what is AI? What can AI do? And then once they started like working on it, there's a whole bunch of issues that come up. So let's say that you are going down like what I would call like the easy path, which is like the path that we recommend if you're prototyping, which is using an API based model, something like OpenAI. There are a whole bunch of issues you can come across, right? So one issue that we have is like scalability. How many inferences do you actually need, and will you be able to get that rate limit? Like, can you get it in the latency that you want? Is data security an issue for you? Okay, if yes, do you need to run it on like a private Microsoft server? And like, there's all of these kinds of issues that you need to think about and deal with, which is a lot. If you've gone down the other route, which is, okay, I'm going to build a model for my use case in house, one of the biggest issues that we see enterprises having is collecting enough fine-tuning data and generating enough fine-tuning data. That's where I think we'll see a lot of synthetic data and augmented data being added to the mix, which is really interesting. And then there's the fine-tuning infrastructure, which is really hard to set up. And then once they actually get to deployment stage, which I would actually say most enterprises are nowhere near this stage yet. They're still way earlier on of trying to figure out where can I even deploy these things. Can I get allocation of GPUs? Can I get it to run in my latency requirements? Do the unit economics work for my use case? Like, there's a whole bunch of things going on at like that deployment end, which I think most businesses and ML engineers haven't even started thinking about yet, which is going to be really, really interesting. So yeah, there's issues all around, but I'm not actually, it's not surprising there are issues all around, considering these businesses are trying to move so quickly in this direction, and the tooling and the infrastructure is just trying to keep up. So, like companies like ours, had ChatGPT not happened, would have been in a perfect place to build the infrastructure layer for this. But actually, these businesses are having to work with early stage startups when they might not have had to work with them before, just because this is the place where you can get a lot of these solutions and a lot of this technology, which is a really interesting innovation in itself.
Yeah, yeah. I mean, I've heard, and certainly from my time at Microsoft, there's this narrative that, oh yeah, only the big companies have the infrastructure, the overall like solution to be able to handle the needs of an enterprise. But from what I'm hearing and from what I'm even seeing from what you all are doing, that there actually is a like there's an opportunity for startups to meet the needs of companies that, yeah, for whatever reason, are not being served by the big hyperscalers and all that. So that's very cool.
Yeah. It's a super cool, like, AI probably more than any other technology is a startup game in a lot of ways. Obviously Microsoft is doing amazing things there, but you're also buying a lot of startups. But this is a startup game more than most other technologies, and that's just because everyone's trying to figure out what the hell is going on, and startups are really good at doing that very quickly.
Yeah, I saw that you recently made a product announcement around Falcon. Is that something that we could see?
Yeah, of course you can. So
So preface, what is Falcon and
What is Falcon? Yeah,
yeah.
apart from being a really lovely bird. So Falcon is one of the open source language models that was released a couple months ago. Was it released by the UAE? Did I get that right?
I believe
One
so.
of the Gulf states. I don't want to confuse them.
One of them.
And it's a really fantastic open source language model. And for context, the open source language models are catching up with OpenAI at like an astounding rate, which is really, really exciting. But these, open source language models are still, pretty big, pretty computationally heavy. And the scenario that we played out in the demonstration that I'm about to show you is, let's say you have a Falcon, and that's the model that you want to run that has the accuracy that you need. But you as a business, will have some kind of hardware requirement that you want to run it on. In this case, we said, okay, you need to run it on CPU. Maybe there's a reason why you can't get access to GPUs and CPUs is the one you want. And then another requirement might be you're building a chatbot, right? So you really care about this being real time. The demonstration on the left, so I haven't pressed play yet, is if I were to run this Falcon 7B naively, just using the out of the box techniques. And as you'll see, it does not meet these requirements for running on a CPU. And then I'll compare that with running it when you have inference optimization. So for example, we've just put it through our latest product. So here in this case, we're asking what are some fun things to do in London? And as you can see, the TitanML server model, which is the exact same model, is already writing a huge amount of text, right? It's just going off and off and off. And the PyTorch one has just written their R in that time. And I think that's a really compelling example of times where you can make a huge difference from using these inference optimization techniques to the point where you can go from a product being non-deployable to being production ready. And this is only a couple lines of code using our latest product, which is really exciting.
Yeah. Could you talk at a high level? What is this magic? What are these optimizations that are happening behind the scenes?
Yeah. So in this case, we actually don't change the underlying model. We're not using any kind of pruning or knowledge distillation or anything like that. Here, we're looking at things that we can do in the runtime to make it run faster on the hardware. So looking at different compilation techniques and quantization is a key thing as well. Yeah. So there's not really a significant accuracy degradation because the model hasn't been changed. It's just looking about ways that we can make this model run more efficiently on the hardware.
Yeah, I can imagine that when doing any of these sort of optimizations, there are probably certain trade-offs that you have to make. What sort of practical trade-offs have you personally seen or your team has seen when doing these sort of things?
Yeah, unfortunately, there's typically no free lunch, although in this case, it's a bit of a free lunch. But typically, when you're making smaller models, you have to give up some level of accuracy. And there's this Pareto front of accuracy versus latency that you can achieve. And the goal is, as you move down to smaller and smaller and faster models, how can you retain as much accuracy as possible? So yeah, unfortunately, there's always an accuracy degradation typically. The hope is though, and what you should be able to do if you're doing these techniques well, is that the accuracy degradation won't be too severe, and it hopefully as well should be much better accuracy than what you could do naively of a model of a similar size. But there's always this trade-off of kind of hardware / cost, latency, and accuracy. And there's typically not a perfect fit, but you can just do your best to try and get the best trade-off you can.
Yeah, and I'm sure a lot of these trade-offs are actually driven by use cases, right? That your enterprise customers are bringing to use, saying that I want to do X, Y, Z. To sort of transition this topic towards something that has been probably more buzzworthy, at least in this space of late, is this idea of agents and more agentic style behavior in large language models. What are your thoughts about that? Is that something that is a fad? Is it actually real? Are these use cases that enterprises are bringing to you?
Yeah, I think so. brief summary, like agents is kind of when you get AI to use AI to do things, and you kind of have this like iterative loop. I think it's cool. I've not really seen any examples yet that make me want to use one. However, if the best models get a lot better, then this will be like a really, really exciting thing. Is this enterprise ready? I don't think so. And the reason I don't think so is because enterprises care about safety and control. They also care about accountability. And would I have an AI running an AI like engage with my client? Probably not. Like that's a bit too risky at this stage. If models get much, much, much better and we can kind of have human in the loop / verification, things that make it a bit safer, I could see it having a bit more enterprise adoption. But one of my co-founders described it a bit like the Roomba of AI. Do you have a Roomba?
I don't, but I know. But, yeah.
Okay. The Roombas are like this little vacuum things. And essentially what they do is they just kind of like random walk through your house and then, you know, they're attached to a vacuum and then they kind of clean up. And if you get your model to like bump around for long enough, eventually you'll get something cool out of it. But you also might come home and your Roomba might have knocked over a vase, which happened to me the other week. So like there's kind of trade-offs. I think it's super cool. I think it has a lot of potential long term. Right now, not enterprise ready. And I also, you know, don't know if the models are good enough yet. I don't know. What do you think about this case?
To me, it's a very intriguing, very fascinating, but also very concerning sort of thing where it's like, oh, are we willing to, we as a species, willing to give up the control, our own agency and give that to an AI agent to do. So like giving access to your bank account, for example, or even your email. Like, would you really want to do that and give that to an AI and just have it run continuously, without any human intervention? I don't think we're ready for that yet, but I would say that people for certain tasks, maybe for certain workloads, right? They don't want to. They might think that, oh, it's like too burdensome or too cognitively taxing to do something like again and again, or something that probably could be offloaded to an AI. And in that case, yeah, maybe you can see some of these agents come to play. But again, I would personally be hesitant to
You know what's interesting
do
about
that.
that take is you used to work with self-driving cars, right?
That's right.
Isn't that the exact same objection to self-driving cars?
So from so there are these like two camps within self-driving even. One is more or less called the engineered approach, and one is like the end-to-end single model deep learning, from input sensor to ultimate like driving control. Uh, I think most companies like the Waymos, the even Tesla and Cruises of the world, right? They follow this engineered approach. They make use of like a high definition map. They use and they separate the concerns from like perception, mapping, planning, control, and all these sort of things, prediction. Um, and doing so, right, allows you to have finer grain control over each particular system, and you can debug and all that. But the end-to-end approach, which several startups are still pursuing, is more or less like you say like, oh, I want to go from point A to point B, and just robot, you figure it out to
Yeah.
how to get there. Yeah, I mean, I think that's the direction that people want to go. But in terms of how people are doing it, and again, going back to this idea of control, verification, safety, it, people lean more towards this more engineered style approach.
Interesting. It's like, because the engineered style is kind of like you have the different systems interacting with each other autonomously, which is agents.
Yeah, I mean, I would say each system has its own separate set of concerns. So the perception is responsible for just taking an image or a video or LiDAR and just outputting the bounding boxes of where objects are in the in the world. And then prediction is focused on, okay, now that you've perceived these objects, how do you what's your forecast for where they will be in 1 second, 2 seconds, et
So
cetera.
I guess what's
So
nice about that is it's explainable.
a bit more, yeah. It's easier to debug. It's and I would say the key idea is that, right, all these systems can be in the engineered style approach can be either swapped in and swapped out. They could be turned off if needed. They could be manually intervened if
Yeah.
required. So not pure agents, at least not yet.
Hmm. Nice. Very cool.
Yeah. Okay. So in terms of, we've talked about kind of like what's buzzworthy right now,
Yeah.
but one thing that I'd be curious to hear your thoughts on is, what would you say is something that people are not paying enough attention to in AI?
Mhm. Great question. I mean, it's my job, but I would say inference. There's been a lot of hype at the moment about like training and who has the biggest training cluster and blah, blah, blah. I think inference is something that is going to be a really important topic over the next couple of years that we aren't talking a lot about because not many people are at that stage of the life cycle yet. So inference, I think, is a key one. Another one I would say is alternative hardwares, besides NVIDIA GPUs. Like NVIDIA is obviously amazing and doing so well out of this, but there are other ways to run AI models. You can run it on CPU, you can run it on like Inferentia or these like other AI accelerators. So I think that's an interesting thing that's going on that not many people are talking about. I have two more. Sorry, I have a lot of things. I think
That's okay.
we talk a lot about hype in this AI circle, so it's nice to talk about non-hypey things. Another thing I'm really excited by is like edge LLMs. So kind of combining our earlier work as like edge computer vision and LLMs. They're not currently good enough, but I'm really excited to see what it'll look like when we have good LLMs running on phones and laptops and desktops. And we're actually really not that far away. Like the Falcon video I showed you was actually run on a desktop CPU. So like we're kind of getting there, and that will be a really exciting transition when we can have like totally private LLMs. And I think like the final one, which I think a lot of the product people have been shouting about, but that's like UI. Like Copilot has had insane uptake in coding, which is awesome. But I think largely it's because of the UI that it's wrapped in, like it's built into your editor. But it'll be really interesting to see what the killer UI will look like in each different field. So like what will it look like for legal, finance, healthcare, blah, blah, blah. Because my guess is it's not going to be a chat box. And I think like a chat box is just kind of like the easy, MVP. So it'll be really interesting to see what those products end up evolving like.
Yeah. Speaking towards interfaces, do you view it maybe incorporating or at least going towards a future that is more multimodal in nature? So kind of
Yeah.
incorporating, let's say a different, even like a experience of, I'm just thinking like Apple Vision Pro, where you're gonna strap a headset to your face and have full like mixed reality, interact with both a digital and physical world.
Mm.
Do you view it kind of going towards that direction, or do you think of something else?
I've I think for like personal AI and when we use AI in like our everyday lives, I think they will be multimodal because we find that really cool, right? Like we do things like gaming and we watch films because they're like they're all encompassing, they're sensory, and they're multimodal by nature. So I think we'll see a lot of that. Like we've seen a lot of personal use uptake of things like Midjourney. However, I don't know if we'll see the same in the enterprise. We haven't seen huge enterprise adoption of Midjourney or these kinds of like non-text-based AIs. My guess is that for a lot of industries, they're kind of too traditional to go the full hog of like, we're going to have this multimodal, full sensory experience of AI. And I think they will limit AI to be doing tasks. So you're not going to have like a full AI lawyer that's, you know, equivalent to a partner. But what you might have is an AI that can help you with referencing or help you draft contracts, or like these really task specific AIs versus like the more full featured sensory AIs that I think we'll see in like our personal lives.
Yeah. Well, certainly it's a exciting future to look forward to, and
Yeah.
a lot of change that could happen. So I guess speaking towards change and even how people can prepare themselves for it, because it is really a disruptive time for a lot of people. There's probably a lot of concern about job loss, about industry destruction, industry creation. So from especially for you coming from a non-traditional background, advice would you give to someone who's looking to either break into AI or even just try to figure out how to navigate this AI world
Yeah.
that we're in?
I think I have a pretty pessimistic view on how this will affect like the economy, the wider economy. I think we're going to see really widespread job losses. And I know people always say, oh, well, it'll be replaced by more industries. This one feels different, and I'm sure they all feel different, but I am actually genuinely worried about what this is going to mean for a whole bunch of industries. And if I was a young person, like let's say I was like an 18-year-old trying to figure out, you know, what I want to do, it's not as easy as it used to be. Like it used to be, okay, if you learn to code, everything will be fine because we're always going to need programmers. It's not entirely, you know, it's not the case that that's true anymore. You know, we will still probably need low-level programmers, but do we need the same front-end developer that we needed? You know, I'm not saying now obviously we do, but in 10 years that we did, you know, that we do now. So that's, you know, a kind of a worrying thing that I think that we're seeing, and I'm not sure what the solution is. So if I was 18, I think my best bet would be, firstly, I would stay insanely up to date with all the latest technologies. I think that's one of the most crucial things when things are moving really, really quickly. And I think we need to be thinking about what are those skills that can't be replaced by AI. So things that we can be really good at as people is, you know, forming connections and learning from other people and really forming that interpersonal connection. I think cherishing and developing that will be really important. Another key skill that I think will be required for the AI future, which is something that I'm really lucky I have from my background, is the ability to just learn things that you didn't know before, didn't have a background in, right? Like I didn't have a background in AI 5 years ago, and like now I do. But it's this idea that like you can constantly learn and constantly improve yourself way beyond school. And I think that's going to be really important when we're seeing like such uncertain times. So unfortunately, I don't have a good answer of like, this is what the career of the future will look like. I just know that it will be really different to what we have now. And like the only thing we can do to prepare is just be resilient and be willing to learn and adapt.
In the spirit of learning, adapting, improving yourself, are there any sort of favorite books, recommendations, movies, even or shows that you you would recommend to people?
Something I watched a couple months ago, which really brought me a lot of joy, and I think like we could always use a bit more joy, is Human Playground on Netflix, and it's this really beautiful 6-part series on what play looks like in different cultures and at different stages of like, you know, your life, and I think it's a really, really gorgeous representation of like the human spirit and human interaction. So I definitely recommend watching that on Netflix. And also another one that I've been thinking about a lot because I'm trying to enact some of the learnings is Atomic Habits, and I've read that a couple times now. And every time I read it, I get like newly inspired of ways that I can improve my life. So I'm a big fan of that. And then another one that I'll recommend is like that everyone has read, Thinking Fast and Slow. I think it's really nice to kind of remind you about the way that your brain works and ensure that you think intentionally about the things you're meant to be thinking intentionally about. So yeah, that's some recommendations. What about you?
One of my favorite books I read back when I was in high school, and it was even an older book back then, uh, was this book because it was very formative for my thinking.
Yeah.
This book called "Amusing Ourselves to Death" by Neil
Okay.
Postman. Yeah,
Mm.
I would definitely recommend that because uh, he was talking specifically about how the medium really influences the message that gets communicated. And in that time, he was talking specifically about television and introduction of this like show business style to even the presentation of news, where news, as we see today, right, is like a very sensational headline meant to grab attention, and it's very difficult to engage very critically on a topic if you only have like a 20-second soundbite to communicate something that's going on. So I really enjoyed that piece. It's an older book now because he was writing for the television era, but I think
Right.
a lot of the same sort of ideas are very present even today. And
Yeah.
so that would be one that I would recommend.
Love that. I'll definitely check it out.
Cool. Well, as we're winding down, thank you, Miriam, for this time. Actually, I really enjoyed our conversation. And for the listeners who want to follow what you're doing or see more, can they find you?
Yeah, so I mean, you can check us out on our website, titanml.co. I'm also Meryem Arik, and I'm on LinkedIn. I'm pretty active there. I also now have a Threads account as of yesterday at Meryem Arik. And yeah, like come learn about us, message us, and yeah, we'll see if we can work together, which would be really great.
Awesome. We'll definitely check her out. And again, thank you, Miriam, for the time. Hope you have an amazing weekend. And yeah, take care.
Yeah, I loved this time. Thank you so much, Alex.
Hey, thanks for listening to Humans of AI. If you're building something with AI or have perspectives you want to share, drop me a note at alex@humansofai.xyz. And be sure to subscribe to my newsletter, Chaos Theory. Until next time, this is Alex, Resident Chaos Coordinator.